So here's our example voltaic cell. We have silver metal submerged in a silver ion solution. We have cadmium metal submerged in a cadmium ion solution. The two electrodes are connected with a wire, and there is a salt bridge connecting the two solutions. I should have drawn that salt bridge a little bit longer, shouldn't I have? Because it's got to make it down into the solution. All right. So the first question that we are asked is, what is the voltage of this voltaic cell? Well, I don't know about you, but I don't have the voltages of all of these half reactions memorized. So you're going to need to look at a standard reduction table. So we can stop, we can do that for a second. All right, so now from the standard reduction table, we saw, so silver was up higher and cadmium was down lower. So I'm gonna write them both down just the way that they appeared on the table. And so it was Ag positive plus an electron produces Ag solid, all right? And then that was at positive 0.80 volts. The cadmium reaction down lower said that cadmium 2 plus 2 electrons becomes cadmium solid, and that's at a negative 0.40 volts. So both of these are reduction reactions. That isn't going to work. You can't have both reduction reactions because nobody's going to be giving away the electrons. And so since the cadmium reaction is a lower voltage, all right, it's a worse reduction, then silver is going to stay this way. Silver is going to be the reduction reaction. Cadmium, we are going to flip that reaction. So we are going to make it the reverse reaction. We're going to make it cadmium solid decomposing or forming cadmium 2 plus ion and 2 electrons. Now, because we flipped that, we're also going to flip the sign on its voltage. We're going to make it positive 0.40 volts rather than negative 0.40 volts. And then I can try to erase that. Oh no, Bix. Oh. All right, well, this is just wonderful, isn't it? All right. So we're back. All right, so we will rewrite that as cadmium breaking down into cadmium 2 plus 2 electrons at positive 0.40 volts. So our overall voltage, now that we have one reduction and one oxidation, then we add that up and it comes out to be positive 1.20 volts. All right, so that would be our overall voltage, 1.20 volts. It asks which side here is going to be the anode and which one is going to be the cathode. Well, the anode is the origin of electrons. The cathode is the recipient of the electrons. You can also remember it that the anode is the site of oxidation and the cathode is the site of reduction with the little acronym thingy, NOx red cat. But regardless, we got cadmium cranking out electrons. We got silver taking in the electrons. So that means that silver is the cathode and that the cadmium is the anode. Direction of electron flow. Well, it flows from anode to cathode. It's going out of the cadmium and into the silver, so electrons are going to be flowing that direction from So am I in the mirror? How am I right now? So it's left, right wouldn't be switched. So this is so it would be from right to left. Okay, because I'm looking in a mirror. So, all right. And then we've got overall reaction. So the overall reaction, now like any of our half reactions, the electrons have to cancel. So since the cadmium is cranking out 2 electrons, but silver is only taking in 1 electron, we would have to take this whole thing times 2. So we'll just distribute that to, it'd be 2 silvers, 2 electrons, 2 silver solids. So the overall reaction, now electrons will cancel. It's gonna be 2 silver ions plus cadmium solid reacts to form 2 solid silvers and cadmium, 1 cadmium 2 plus ion. And then the last question is, which electrode is going to lose mass? So let's think about this. So here's our overall reaction. So during the course of the reaction, silver ion is going to become silver solid. So what's going to happen, this pink solution that we have drawn here, the silver ion is going to come out of solution. So this electrode is going to get all grubby, right? Because the silver ion is going to accumulate on the surface, and that solution would actually get less and less and less colorful. It's going to turn more and more clear. On the other side, you got cadmium solid becoming cadmium 2 plus ion. So this electrode is going to be eaten away. It's going to be fading out, and then this color here, the green color, would be getting darker and darker and darker because it's got more and more and more ions. And so then this voltaic cell would stop functioning when either the cadmium electrode is all used up or the all of the silver ion is taken out of solution. So that is a voltaic cell, pretty standard. It's pretty simple combination of 2 half reactions. And if you know how to read a table with any sort of, proficiency, then you should be fine to do voltaic cell problems.